Have you ever done a physics experiment and got numbers you didn't think were correct? What did you do? Freak out? Think your numbers were wrong? Change your results even? Well, here, at the University of British Columbia, researchers are trying to develop a way to give students the confidence to trust their results. Doug Bonn is the lead researcher working on this project.
So I'm Doug Bonn. I'm a professor in the physics and astronomy department at UBC, but I'm also involved in learning how students learn in labs. So I have a sideline in what's called physics education research, where we study student learning and how to improve student learning.
Dr. Bonn created an environment where students had to apply critical thinking skills to the results they obtained in the lab. In a first-year physics setting, students had to compare the results they obtained in the laboratory with other students' results, as well as with the knowledge they learned in class. He then allowed time for students to reflect on their results and then act on their results by making improvements to their experimental design. This process is called the comparison model, which Dr. Bonn discusses.
Take multiple trips through these cycles to try and figure where the issue is in the experiment. Then another piece gets added to this, because sometimes it's not your measurement that needs to be better, sometimes there's a problem with the model.
This comparison model may sound confusing, but it is actually similar to making a batch of cookies. When you are making cookies, you first find a recipe from your mom or a Cooking for University Students recipe guide and follow the instructions carefully. You prepare all your ingredients: flour, baking soda, eggs, sugars, salt, butter, and so on. You follow the recipe step by step. First, mix the dry ingredients, flour, sugar, baking soda, and salt in a bowl. Then stir in softened butter, eggs, and vanilla. Finally, adding the chocolate chips and mixing all the ingredients together. Now that you have yummy cookie dough, find a pan and divide it into spoon-sized chunks. Finally, you get your cookies into the oven. When they have cooled, take a bite and ask yourself, is that tasty? If not, compare your cookies to other cookies you have tasted. And then you can use this knowledge to find different recipes from bloggers, YouTubers, or other recipe books to make your cookies even better. You may ask your friends or your mom what they think went wrong. Here you are making a comparison and reflecting on it, exactly what the comparison model does. After knowing what went wrong in your first cookie making attempt, you can improve the recipe for next time. In this way, your cookie making skills become better and better, and soon you will have the yummiest cookies on the block. Now, back to physics. When this comparison model was used in the physics lab, Dr. Bonn and his team found that students who used the comparison model were 12 times more likely to make changes to improve their experimental methods. They were also 4 times more likely to identify and explain limitations of physical models by their data. They also showed much more sophisticated reasoning about their data. This kind of comparison model is key in developing critical thinking skills. We may not realize it, but we use critical thinking skills constantly in our everyday lives, even in simple tasks like baking cookies. Developing these skills will help you succeed not only in university, but also in life.